Hello, this video is to help you get started in the high adventure science activity, Is There Life in Space? So go ahead and go to learn.concord.org and you will probably have to log in. If you have not yet registered, if you're new, talk to me. I'll get you a course code so you can register. Everybody else, go ahead and log in using your Google account. Now this is my dashboard. You can see that I have your classes here, and the one we're doing is called Is There Life in Space? So I'm going to go ahead and just click the preview button. You can see that some students have already begun this. Okay, we start off with the first page, Is There Life in Space? The best way to complete these modules is to take the time to go ahead and read the instructions and then fill in the question answers as accurately and completely as you can. This one, as the others will have some computer simulation models in there, so you should make sure that you can manipulate those for your quiz or test. Okay, it says in this one that it contains 6 activities to explore the question, is there life in space? It says you'll discover how scientists find planets and other astronomical bodies through the wobble, also known as Doppler spectroscopy or radial velocity, and transit methods. You'll then compare zones of habitability around different star types, discovering the zone of liquid water possibility around each star type. Finally, you'll explore how scientists use spectroscopy to learn about atmospheres on distant planets. You will not be able to answer the question at the end of the module, but you will be able to explain how scientists find distant planets and moons and how they determine whether those astronomical bodies could be habitable. So we start with constructing an argument about space. Now, if you've not done any of these before, you should do part 1, Introduction to Argumentation. Most of you have seen this at least twice, so we don't have to revisit page 1 in this activity. So we're going to start with page 2. Page 2, the question is similar to Earth. It says, as of May 2016, NASA's Kepler Space Telescope has found hundreds of planets outside of our solar system. The graph shows the locations of some of the newly discovered planets. The diameter of each circle shows the relative size of the planet. Venus, Earth, and Mars are shown to scale. So let's take a look at the diagram. Okay. So we have Venus, Earth, and Mars. And then here's a bunch of the planets that were discovered as of 2016. The green shading shows the likely range of the habitable zone where liquid water could be possible on a planetary surface around each star. The closer a planet orbits its star, the more energy it will receive and the hotter the planet will be. The farther a planet orbits its star, the less energy it will receive and the colder the planet will be. Scientists think that habitable planets are likely to be similar to Earth in size and location within the habitable zone. So here's Earth. You can see it's within this green habitable zone. And the graph shows surface temperature. All right, we'll say that this is in degrees Celsius. It doesn't say. And then energy received by the planet. So this is compared to Earth. So Earth is at a 1. And so this is, if you're this far away on the far to the right on the graph, you'd have 1/10 of the energy received. Okay, you should answer these questions then. It says it is important to make sure that you understand the data, which could be a graph, table, or model, before you start to write your scientific argument. So the first question is, what star type has the highest temperature, orange or yellow? Okay, you can see that on the side. It's comparing star colors and the temperature increases as you go up. And so if you can see those colors, hopefully you can answer that just fine. Based on the graph, which of these planets is the largest? You should find Earth, Kepler 1606b, and Kepler 62e, and compare their diameters. And finally, question 7, which of these planets receives the most energy from its star? Right? And energy from the star is based on proximity to the left side. Things near the left side of the graph get the most energy from their star. Next, it will have you select a claim. Based on the graphic, which planet is most likely to be similar to the Earth? Of these listed, Kepler 1229b, Kepler 442b, or Kepler 452b. So find those and make a decision as to which would be most similar to the Earth, and then explain. Now it says over on the left side, a good claim is based on evidence that can come from graphs or charts and may also come from models. And to write your explanation, you should cite specific evidence that backs up your claim. When there's a graph or table, as in this question, you can cite evidence directly from the source. So explain why you think it is most likely similar to the Earth, and give me the reasons why. When there's a model, you can describe what happened in the model, and a good explanation combines evidence with scientific knowledge. So here's an example of an explanation that correctly cites evidence from the graph. This one says, the planet most likely to be similar to Earth is Kepler 442b. This planet is just a little bit bigger than Earth, and it's only a little bit further into its habitable zone. It has a different star type than our solar system, though. Kepler 1229b is closer in size to Earth, but is much farther out in its habitable zone. It is close to where Mars is in the solar system, and Mars doesn't have life on it now. It's also a star type that's very different than our solar system. Finally, Kepler 452b has the same type of star as our solar system, but it is much, much bigger than Earth. It's also on the very edge of the habitable zone, which might mean it's hotter than the Earth. So that you would pick a certainty rating. How certain are you about your claim? Not certain at all to very certain. And then explain what influenced your reasoning. It says a good certainty explanation will explain why you're certain or uncertain about your response. Some topics are more certain than others. Consider the completeness of the evidence, biases in the evidence, and changes that could affect trends over time. So here's an example of a certainty explanation that's based on evidence. I'm not very sure of my answer because there are a lot of factors that go into making a planet habitable. The temperature of the star makes a difference in how much light makes it to each planet. A planet with a dimmer oranger star might not be like Earth at all. In that case, Kepler 452b might be most like Earth since it has the same type of star. However, Kepler 452b is so much bigger than Earth and closer to its star that it might be too hot to be like Earth. It might be more like Venus, which does not have any life at all. When you're done with this, that will complete activity 1 in this lesson, and you will start activity 2. Activity 2 has 4 parts to it, and it discusses the vastness of space. So in this one, you're going to start with a video clip from Professor Deborah Fisher from Yale University. She will describe how scientists are looking for planets outside of our solar system. Use data on the number of known galaxies and stars to speculate on the likelihood of finding planets or moons that can support life. So click on Begin Activity. And the first one is about, are we alone? Are we alone in the universe? Does life, any form of life, exist on another planet or moon in our own galaxy, or in any of the countless others that exist? Whether there is life outside of Earth is one of the most important unanswered questions in science. Scientists are currently searching the universe to find habitable, Earth-like planets. They have developed techniques that take advantage of advances in engineering, science, and computer modeling. Watch the video to get an introduction to how scientists hunt for planets from Yale University astronomy professor Deborah Fisher. She'll play that video and answer the questions. Part 2 talks about how many stars exist in our galaxy and of the Hubble telescope, and asks these questions. So, do you think it's probable that scientists will find a habitable planet in your lifetime, and explain? How certain are you, and what influenced your certainty? Part 3 is on evidence for life, and it talks about what something needs to have life on it and how to look for evidence. Answer the 2 questions about evidence for life, and go on to the last part. What does life look like? And this talks about the extremophiles, as were discussed in one of the videos we watched. And then you will choose what type of living things do you think scientists are more likely to find on other planets, and explain your answer. So that is it for today. You're to complete activities 1 and 2 of the HASBOT module, Is There Life in Space? Let me know if you have any questions, and we'll have this due no later than Wednesday by the end of class.